Welcome back to the workshop and welcome to this ongoing quest to add some small improvements to this drill press. Earlier in this series you saw me add this motor and drive system so I could move the knee up and down. So now I think it's time to turn all this into this. Let's get started. Okay, so those of you who followed this channel for a while, you'll know we've made quite a few custom enclosures. So this is the inverter that runs a 3-phase motor and some other control systems in there. You might also remember I fitted this electronic lead screw from Cloud42, so this is the control system here, and then we have the main enclosure up there with all the electronics in. So there's a power supply, a little microprocessor there, 5-volt supply and so on, and yeah, that works really well. And some of you are probably familiar with the CNC machine I built a few years ago, and then the custom control box which is up there. So inside there we've got the custom power supply at the top there, the inverter top left, a load of switch gear and relays, and the control unit down there, and then all the stepper drivers. And you'll notice that this one actually is made of scrap bits of wood. Obviously that wouldn't pass the test for a commercial environment. You haven't got any EMC shielding, and you know there's the aspect of fire to consider as well. But every time I use this in my home workshop I'm stood basically right here, and it's been like that for years, so I'm pretty happy with that. The reason I went for that is I just couldn't find the cabinet of the right size. They tend to get really deep when they get this big. Also they're often very expensive, so I went with that option. And so for the enclosure for the knee, I did look around at a custom box. The only place, well, it needs to be next to the drill press, the only place I could find really was this space here. The other side was my original plan, underneath the controller there, sort of a panel there, but you can see it's going to get close to this, hit this, block access to the plugs and switches back there, make it a bit awkward on the arbor press. So in the end I decided it had to go this side, in this space here, and I didn't want it sticking out too far because this workspace down here is basically my my swap space. This is where I build stuff. It's getting smaller and smaller as I add more stuff to the workshop. So I didn't want it sticking out too far, and as soon as you get an enclosure, a metal one of that size, they tended to start to become quite deep, as you can see there. And I just couldn't find one that was just the right size without being too deep. So I thought, alright, we're going to go the DIY route. I don't have a CNC plasma yet. That would be nice. Then I could cut out a custom enclosure from steel. So we're going to go back to the wood route. So I decided to make this one out of wood. It'll all be sanded, filled, painted, and hopefully it'll look quite nice. It'll look like a proper enclosure. Now I did go ahead and look around for a supplier of this plywood rather than going to my local hardware store or B&Q, somewhere like that. You know, it's quite a low grade plywood. This is AA or AAA or something. Really nice, free of knots. And the seller had a good reputation, and they also agreed to do custom cuts from me. So they did the two sides, the top, there's a door here that will go on as well with hinges, and all the control panels will go sort of up here and down here and so on. A couple of things though. One was, yes, they say they'd do the custom order, and they relisted it, and I just clicked OK, not realizing that there was about a 4 or 5 week lead time on that, which is a bit annoying when you're used to eBay being within a few days. Anyway, so that was that. So I had to wait a little bit for that project to get the parts. They finally arrived. We're on Saturday now. They arrived Tuesday, and some of the parts had been, I mean, first of all, it's beautifully finished. It really is top grade plywood, really nice. But some of the parts had been double cut. Like cut once and then cut again, so they had like a kind of step in them, so they're not going to fit quite square. So I've had to work on some of those. And one of the parts was missing, which was the backboard. So it's basically supposed to be a board like that, a little bit bigger, and all the electronics would go on that, and then we could get going on it. And so all those parts arrived Tuesday. I realised they were missing. I sent photographs and emailed the supplier Wednesday. It's now Saturday. I've heard nothing. I said I urgently needed the parts because I need to get the project going. So I don't know if they're going to send that as an order, a refund, partial refund. I just don't know. So I managed to find this. It's just a bit of chipboard, cut it down to size. I've made a bit of a start on it. It's going to be okay. It wasn't ideal. I would have preferred plywood, just a bit nicer material to work with. But that's what we got. That's what we're going to go ahead with. Now, interestingly, when I ordered that wood and all the custom sizes, exchanged a few emails. I said I do have a YouTube channel. I'm quite happy just to give them a shout out. You know, there's no discount. I didn't want anything like that because I'd seen good reviews. But I think now we'll just leave it. I won't even link to the company. We'll just go ahead with this. This is where we're at. Right, so I'll give you a quick guided tour of what we've got and what the plan is. Now, I've drawn all this up in CAD so to make sure everything was going to fit. These represent the wire guides or the channels, and then I did try laying out all the electronics so it's all going to fit okay. This will be the top end. These are vent holes. I've put them at the back because this will be stood off the wall about that much on spacers, because I've got to overcome this finishing piece here so it'll kind of stand out a bit. It'll make a bit more sense later. So they're the vent holes, and also because they're on the back, any dust that comes down, it's a bit harder for it to get in, and the air will normally be going up because this is up and that's the bottom there. So there'll be on the door custom control panel or machine out of aluminium with all the 22mm go, stop, speed control and everything. And then at the bottom will be where all the connectors come in, the GX16s, power, all the rest of it, and anything going out, so everything as well. So it looks like it's going to work. We've got two little holes here which I've 3D printed some little spacers. I love my 3D printer. So many uses for that. So they'll space it off the wall and then allow you to screw through. I mean, I nicked the idea off the IKEA cabinets, wardrobes, if you ever got any of those, because you have skirting board, they tend to give you a spacer at the back that's pushed in. So basically the same thing. All right, I think, so what we're going to do next. Let me show you roughly how it's going to look. So I've already 3D printed this little control box here. This will have the low voltage electronics. So we've got our base piece. You can see I've already used my heat insert tool to push in some little M3 fixings in the corner. It went okay. And then these came from, originally they were on these little DIN rail mounted connectors. So that was mounted on, that was mounted on top of there. So I just took those off. Now ideally, I should have added some little like upstands, just tiny little ribs either side to stop these rotating when you're doing the screws up, because it's only held in there, but you're on that on one screw. But we'll see how we go. And so that's the 5 volt, a 0 volt, and then we needed a 2.5 volt supply as well. And then there's a matching lid that will go on there as well. And then this side will be open because this will be next to the trunking for all the wires to come in and out. So it kind of look like that. All right, so that will go up there. And then we've got all our power supplies. So we've got our 48 volt and the 24 volt. So this one will drive the stepper motor up and down, and this one's for the stepper brake. And then you'll also see I've 3D printed some little clips to hold those together, and then I can just screw it down at these 4 hole locations. Yeah, so I'm really getting into my 3D printer. Now I did have a couple of issues with that, so that'll go back there. I'll just grab those. So the first one I made looked like that, all looked nice. It was a nice fit on the CAD I'd downloaded from GrabCAD, and they looked exactly like these. Only problem was these units I've got are considerably taller, so you can see that when I went to fit them, it was never going to fit. So, and ironically I did confirm the width and made sure that was going to fit. I just didn't measure the depth, so they weren't going to work. So no problem, hop back into CAD. Now that all these dimensions were tied together, or so I thought, so I adjusted that, so that was going to fit fine. But as you can see, this one I forgot to, this one I forgot to alter. You can see it's considerably shorter. So that wasn't going to work. So back into CAD, adjust them all to the correct length, and then printed 2 of those, and there we go. So those hold those down, and then our little 5 volt supplies there to run Arduino. Then we've got our little stepper driver here. And again, I went ahead and I've got to clean those out there, but made a little bracket, So that will go onto there. There'll be a threaded insert there and there, and then we've got our little screws to hold that down, so that will go about there. This is the relay that the Arduino will control. It'll actually send 24 volts out to the stepper, so that's at the top here. And then the last one, now the Arduino is still here and it's still wired in to limit switches and some of the control gear when I was practicing how it was going to look. So I want to leave that, so I've got kind of surrogate piece there, and that goes over here. I think it will go that way around like that. So cabling can come around, drop into this side or that side. We can drop into either side of that, and then we've got our power distribution at the top there for very low voltage. So I think they are the main components. And while I was in a 3D printing mood, the bottom part here, there'll be an aluminium panel which we need to machine, which will have all the inputs and outputs on it. And because this top edge is unsupported and it's only 1 or 2 millimeter aluminium, you'll be pushing connectors in. I thought, why not reinforce it? So again, back to 3D printer, made this, and it will go on like that. And then there's a leg that this stands on, because this will be the bottom. It will stand on legs about that long off the workbench. So again, to give it some strength and feed the load up into the side. So there's 2 of those. Also holds it nicely together. It's got 2 of those kind of custom angle brackets. And then while I was at 3D printer, I thought I'd have a go using my first ever attempt at some print in place, I guess you call it, hinges. And I guessed what the gap might be, and they did stick ever so slightly. But once I'd broken, as you can see, once I'd broken the tiny contact, I got some hinges that are completely self-contained. Now the nice thing about that accident is when you go and shut the door, it will kind of sort of ratchet shut. I don't know if you can imagine of that leverage effect, it will kind of hold it in place. So that's quite a nice bonus effect. So they'll obviously go down here. I think I'm going to put 3 on just for extra strength, because these are only PLA after all. We'll see how we get on. Tiny screws, so they'll go on there, and then as we mentioned a while ago, the door will go on there. So the ins and outs down here, and then the main control panel. So we need to machine a window in here, and we'll insert the aluminium control panel in there, and that'll have all your buttons. That's the basic idea. This will all be clean, sanded, sprayed up grey. It might look a bit like a control box, proper control box from a distance. So that's the plan. So I think the first thing to do is hop over to the CNC machine, and we'll machine out the control panel that goes onto the door. And after a bit of a clean up, it looks like this. So I'm really pleased with it. So you get a bit of an idea about what it's going to look like. So that will go on top of the door panel like that. And we've got e-stop, speed, up, down, and then there's a 3-position switch that will go in there. That's continuous motor running. That's steps. So you push that and it will just move 1 mil, 10 mil, whatever. And then in case I write the code for it, we've got the drill cycle there. So it would drill a certain amount, a certain peck, a certain depth by lifting the knee. May never use it, I don't know, but it's only a bit of code, so I thought I'll put it in anyway. No, nothing lost. This will be the 5-button keypad, so you can interface with it and change any parameter settings on any of these. And then a little screen to show if you're going up, down. It's all, you don't need this. You could just add a drill, drive through a little motor and whiz it up and down. But I love making it complicated and I love having fun, so this is my version of how to move a knee up and down. Yeah, let's go for it, shall we? The other thing you'll notice then is these little, I guess, graphics you might call them, and you might be thinking, how have you done that? Well, 3D printer obviously is the answer, and obviously I've got the P1S with the 4-colour AMS, so I'm able to do multicolour prints. So I've got grey there, and then you'll see the buttons that are black are raised, I don't know, about 5mm or so. And then for the e-stop, you can paint on it and tell it what colours you want for different layers and things like that. I wanted red, but I don't have red, so I've gone for orange, and that's the e-stop button. So that's great, and I printed that out, and because that's drawn in CAD and that's machined in CAD, they're a perfect fit, it just drops in. But I wasn't entirely sure how I was going to hold this little strip in place. I really didn't want screws coming through here, or pop clips out of the plastic, or like a really tight fit on some of these to try and push it in. It's bound to fall out over time. And then I had the idea, well, why not just drop tabs down and get them captured by the 22mm buttons. So that's what we got, and that'll hold that nicely in place. So that's the door control panel. Okay, so the next thing to machine up is the control panel that goes at the bottom there with all the inputs and outputs, power, signals, that kind of thing. So again, let's hop over to the CNC machine and get that cut out. And after a bit of cleanup, here it is. So we've got, this is not going to be forced with a fan, it's just to allow the air to come in. We'll have power in and out, because I'm going to have mains power coming in, and then it will daisy chain out and go off to the DRO, so that once you switch this on, this and the DRO come on together. And then over here we've got GX16 controls for, we've got the stepper motor, the brake, I can't remember the order I've done it now, but anyway, stepper motor, brake, the upper and the lower limits, although I might combine them into one 4-pin plug, have the upper and lower together, and then have one spare for something. So that's what it looks like. And then these holes here are, because this will be facing down like that, and then there'll be a leg like a 10-12mm aluminium sort of foot, so actually it'll be sort of that way around, and then that little corner bracket with the nut will go into there, and the leg will have a thread on it, so that will thread into there, and then that will come up the side kind of like that, and then there'll be a leg here down to the bench, and then you can get all the controls in. Alright, so far so good. So I think we'll start getting the top panel glued and screwed on, so we've got a nice reference for everything else, and it's not really going to get in the way up there. Okay, so I've got the top glued on, screwed on, I've got the sides in place, got all the holes drilled and got those screwed there. To make it easier to make and assemble and drill all the holes for the electronics, I'll probably take these sides off again, but I wanted to establish, you know, some kind of datum so I could get all the holes in place. Now either these won't be the final screws I use, I'll see if I can find some that are sort of cap head or something like that, or countersink these in, because obviously these stick out proud, but just pinning it in place for now, just so I've got the holes established, because this has all got to be stripped down, sanded, clean, painted, and then it can go back together. But I want to make sure I've drilled, sort of assembled all the holes, so I'm not doing that once it's painted. So next I need to put the door and the hinges on, so we'll just put a couple of layers of tape just to space it out. I don't know how much we'll need, but we'll just put 2 on. Okay, then here's our door. Now we've still got to cut the big hole out. We'll do that on the CNC machine where the main control panel goes, but nothing's stopping us getting the hinges sorted out. So we'll take a few minutes, make sure it's definitely lined up, because the hinges have got no adjustment on them. I was just looking at where these hinges would go, and obviously go something like that. The hinge centre line's got to be on the, obviously on the parting line there. And I was just looking where I've put these holes. They are, you know, about that far into that 12mm ply. So what's that, about 3 or 4 mils? So I'm very worried that that screw is just going to rip through this. Maybe not immediately, but it's not going to be very good. And I can't move those down anymore where they are. You can already see that they're close to, it's actually come through onto the moving side. So I think I'll have to design these so they're longer, so the screw's actually out here somewhere and nearer to the centre line. Maybe, well, the bottom ones aren't so bad because they're right into here. In fact, the further down the better. Either that, or I'll just look for some standard sort of just regular butt hinges, some small ones to go on there. I'll go and have a look and see what I can find, and then if I can't find anything, I'll redesign these. Right, I've had a bit of a rethink about the hinges. So these are the originals. Don't drop it. Yeah, it worked pretty well. I actually printed that without supports, and it just obviously got a bit of material caught on there, which was okay. You know, it's still functional, and added that extra kind of click shut function. But they were too close. These holes were too near the top, so it was going to break through this plywood. So anyway, they worked without supports, you know, and that was an option, but a bit risky. So what did I do next? I think I did one of these two next. Yeah, so I think I did that one next. Completely redesigned, much bigger, much beefier, and put the holes in the centre of the plywood, so 6mm down instead of right near the top. And as you can see on this one, without supports like I did on that one, but this time it caught in so many places that it basically bound up, and I ended up just trying to snap it open just to see where it was caught. In terms of the sort of captured pin mechanism, that seemed to print okay. So as a mechanism it would have worked. It was obviously just jammed up in too many places. So I had another go and I improved the clearances, but I'll focus there out. But unfortunately, same thing. I've tried to clean them out with a little screwdriver as best I could, and eventually just tried to pull it apart just to see where it was broken, but I couldn't. It actually broke here. So then I've just literally just printed or designed another one here, and you can see one thing. Obviously I've decided to, there's no point in leaving that like that. I've added a bit more material, so strengthen those up because they're a little bit weak anyway. and this one I printed with supports, and I just use a little tool just to scrape out the little bits and pieces, and then finally it came free, and then I just cleaned up all the loose edges, and here we are. So you can see there's a little bit of the infill material there, support material, but it does actually hinge quite smoothly. Now, because I'd added a little bit more clearance around different bits, there's a tiny bit of play in that, but I guess that's no bad thing. We'll set it so it's fully down when it's screwed together with gravity that way, so that's as low as it will go, and I think that'll be okay. And then, so that design looks okay, and I've got another one printing over here. So I'll just hit go again and it's just printing another one inside the house, so that will be done in, I don't know, half an hour. There we go. Yeah, you just get a update every now and again. Right, looking good. Oh yeah, it's just a nice fit in there. Maybe take it off. Yeah. Sinks, but hopefully if I drilled it in the right place it will stay. Okay, let's pull it out. Okay. Now when I printed these, I think I went with 4 layer walls just to try and almost get that like 100% filled in there, because if it's going to break, it's going to break probably around that point there. Not much I could do about it because that is the design of the hinge. It's got to have all those leaves, but see how we go. If I put 3 on, hopefully it'll be okay. Right, so I printed out a second one and screwed that on, as you can see. So let's see how the door opens. Ooh, okay. It wants to hold itself there, but I don't want to break that. Alright, so I'll take this out. Okay, looks good. It creaks a little bit. If that's the plastic or if the wood is catching. No, so where the pivot point is, it should bring the wood away. It should never try and go back into itself. So yeah, it must be just the plastic making a bit of a noise. I don't know if you can grease PLA or if that gets upset, or WD-40. I'll have to look into that, or I'll just leave it. I'm sure it will bed in. Alright. And in terms of, yeah, it feels pretty rigid. I might still go ahead and print the third one out, but for now, I think the door hinges are done. I haven't made the little feet that go on the bottom yet, so I decided just to use these little M8 bolts just for now, just to get everything lined up. I also decided to add a third hinge just to give it a little bit of extra strength. Then it's time for the cutout, so I needed to mark that up. And then took it over to the CNC machine and machined it out. Okay, well there it is, basically complete. So you just saw me, I just freehand CNC'd out that slot there. It didn't quite fit on the machine, so I had to do 90% of it and then move the board over and roughly get it back online and then machine the last bit. But anyway, we got there. So hinges are on, got our panel on. I need to countersink these screws, but for now they're in the right location. And then we've got our little screws here just to hold these corners in. There'll be some kind of bars about that long with a thread on, about 12-15 mm diameter, and they'll be the feet, giving you space to put the connectors in there. Right, so I think the next thing to do is clean all this down, take it apart, probably in different order actually. Take it apart, then clean it down, and then spray it silver, and then I think we're ready to put the electronics inside. Well, I think this video is getting quite long, so it'll probably be in the next episode. We'll get all this painted, get everything laid out, get the electronics in, get all the switch gear in up there, all the ins and outs, and we'll start putting it on the wall. So it's good progress. Pleased with that. Okay, well I hope you enjoyed this video. Feel free to subscribe if you want to see a little bit more of this project. And all that remains to be said is thank you very much for watching, and see you next time.